Okay, we're going to talk about empirical and molecular formulas now and how we calculate them. They're very much not different too much from one another, but they do, however, have a slight difference. Both of them require that you start out with a percent composition, and since we just learned how to do percent compositions, it's fitting that this comes next. The empirical formula is the simplest whole number ratio. It's the simplest ratio of elements in a compound. In comparison, the molecular formula shows the true mass. The molecular formula is going to be a multiple of the empirical formula. It can often be the same, but it is also often different. To calculate the empirical formula, the simplest whole number ratio, we're going to start with a percent composition, and then we're going to assume 100 grams. When we assume 100 grams, we change that percent into a gram. The next thing we're going to do is divide that element, the amount of that element, the grams of that element, by its molar mass to determine the number of moles. To determine the lowest whole number ratio, we'll then divide by the lowest molar value. If necessary, we'll multiply by a common factor, and we will make them whole numbers. The molecular formula is just one more step. We're going to take the molar mass of the molecular formula, that's usually going to be given in the problem, and we're going to divide it by the molar mass of the empirical formula. This is going to come out to some whole number n. That's going to be our multiplier, and we're going to distribute that through our empirical formula to get our molecular formula. This is a whole lot of talk right now. Best to just go ahead and do a problem. So here we go. Here's a problem. A compound contains 25.9% nitrogen and 74.1% oxygen and has a molar mass of 216 grams per mole. What is the molecular formula of this compound? I'll start this out by writing exactly what I have. I have nitrogen, 25.9%, and I have oxygen, 74.1%. Step 1 is removing the percent sign and changing it to grams. So we're going to change this to 25.9 grams and 74.1 grams. So step 1 was in blue. Step 2 is going to take each of these and divide them by their molar mass. Nitrogen has a molar mass of 14 grams per mole. Oxygen has a molar mass of 16 grams per mole. When we divide this out, we get that there are 1.85 moles of nitrogen and 4.63 moles of oxygen. The next step in the process requires that you determine the lowest whole number ratio. This is accomplished by dividing both of your values, or all if there's more than two, by the lowest number. 1.85 is much smaller than 4.63. When we do this, on the top we get an easy value of 1. On the bottom, however, we get a value of 2.5. The final step in the process would be multiplying by some common number. We can multiply both of these by to get a whole number. Well, if we have a 0.5 here, what we're going to multiply is 2. What we then find is that we have 2 times 1 is 2, and 2 times 2.5 is 5. This means that our empirical formula is 2 n's and 5 o's. All of this work right here has yielded us the empirical formula. On the next page, I'm going to show you how we're going to use that 216 grams per mole. So we had from that previous page N2O5. And we also had that the molar mass of the molecular formula was 216 grams per mole. The equation that we're going to use is taking the molar mass of the molecular formula and dividing it by the molar mass of the empirical formula. Well, the molar mass of the molecular formula is given to us, 216. We have to real quickly calculate the molar mass of the empirical formula. 2 times N is 28. 5 times 16 for oxygen is 80, plus the 28 from nitrogen is 108. When we take 216 divided by 108, we get an N factor of 2. We can then take that N factor, 2, and distribute it through our empirical formula. 2 times N equals N4. 2 times 5 equals O10. N4O10 is our molecular formula. And this is how you solve problems like these.